Okay, good morning and welcome back. So, hope everyone's doing safe or staying safe and doing well. Last class before your spring break, so remember no classes next week, and then the following week we resume our normal schedule of Monday, Wednesday mornings. Okay, so I think yesterday I updated your grades for the last few assignments. All right, and so you should see updated grades for example 3.1. 4.3 and 4.4, right? And then this one's not due for a few weeks. Okay, so you should have grades either a 1 or a 0 if you did it. For these, I guess we've done 7 assignments so far. 1, 2, 3, 4, 5. So yeah, so if you see a 7 in the column that says assignments all, then you've done all the assignments and you have 100%. So that we've done 7 total assignments. And for assignment wise, the total amount you can have right now is 7. All right. And yeah, and so if some students have missed a few, don't worry too much about it yet, but don't keep missing them. I will have some extra credit opportunities for some assignments in the future, and so you'll have an opportunity to make up some missed assignments. Not, I think I have 3 or 4 makeups, so don't miss too many, but you can make up a few. Okay, so we're going to do the last assignment before spring break. And so the curve fitting thing that we did on Monday and example 4.5 we're about to do today, those two will be due the Monday when we return from spring break. So you can post those whenever you're done, but not due officially for a couple weeks. Okay, so and then I'll get your exam graded probably sometime this weekend. All right, and okay, so example 4.5. This is the one we're going to do today. So you can go here in Blackboard, you can open up example 4.5 Word document. Okay, you can open up the drug production Excel file. Okay, and then we have some practice problems, but we'll get to those later. All right, so let me read I think there's a synopsis here for this one. Okay, so this is example 4.5 drug production at Repco. Repco produces 3 drugs, A, B, and C, and can sell those drugs in a limited quantities at prices of 8, 70, and 100 respectively. So A is 8, B is 70, and so on. Producing a unit of drug A requires 1 hour of labor. Producing a unit of drug B requires 2 hours of labor and 2 units of drug A. And producing 1 unit of drug C requires 3 hours of labor and 1 unit of drug B. Any drug A that is not used to produce the drug B can be sold separately, and any drug B that is not used to produce drug C can also be sold separately. All right, we have a total of 4,000 hours of labor to use. That's our labor constraint. And Repco wants to do a little model and maximize its sales revenue from selling these different types. All right, so we have A is the cheapest drug. We can sell that individually or use it in like a blending or combination to make drug B or drug C, and the same with drug B. So A or B can be sold separately or be used in drug C. B can be sold separately or be used in drug C, or A can be sold separately or be used in any of the drugs. All right, and then we'll see that what we choose to do is going to depend on how much we get like for the labor hours. So we're limited by labor. Okay, so we're going to decide which drugs to sell based on how many hours it takes to make them, and their selling prices, and we'll try to maximize our sales revenue. All right, so here you go. If you look at the model, the spreadsheet, you see that these are the hours that go into drugs A, B, and C, 1, 2, and 3, and then you need drug A is just sold separately. You need 2 drug A's to make a drug B, plus 2 more labor hours, and then 1 drug B to make a drug C, and then 3 more labor hours. And then these are the selling prices of those drugs on the market. Okay, we're gonna be constrained by our labor hours, and we're trying to maximize our revenue from sales. So there's no cost, I guess. The only cost is we don't have to pay for labor. We're just deciding how to use that labor most efficiently. Right? So the labor budget's already been paid for. We just have to decide how to use that labor to make the most revenue. All right, so example 4 of 5, drug production at Repco. So first thing we'll do is we'll highlight the inputs light blue, the decision variables light red, the objective highlight yellow, and we'll note the constraints, right, with the inequalities. Yeah, so that's step 1. So, okay, so we got a bunch of inputs. These labor hours here for drugs A, B, and C, those are inputs. You can highlight that area light blue. Okay, also the number of the drugs that go into each type. This area, that's also input range. You can highlight this area light blue. Okay, the selling prices, those are inputs, light blue. What do we so we're deciding how many units of each drug to produce. That's what we're deciding. Okay, so that means that this range, B16 to D16 is our decision variable range, so that's going to be the light red color, yeah? We've got 4,000 labor hours to use, that's an input. And finally, our revenue cell is the objective, so that means we're going to maximize cell B25. That's the highlight yellow color. And we have a couple constraints, I think. Okay, the first is that we can't use more units than we have in production. So this, for drug A, this has to be bigger than or equal to this. And the same for drugs B and C. So let's put an inequality of greater than here, here, and here, starting in B17. Okay, so this has to be bigger than or equal to this has to be greater than or equal to this, and this has to be greater than or equal to that. All right, so that's our first constraint range, the production constraint. All right, and we also have a labor constraint. We can't use more hours than we have. We can't use more than 4,000. So let's put a little less than or equal to in C23. Okay, so production constraint, labor constraint, and we're gonna decide how many units of each drug to produce and try to maximize revenue from sales. Yeah? All right. Step 2. Let's create range names, and if you have the textbook, it's in figure 433, 4.33. Okay, so we need range names for um, both sides of the constraints and the decision variable range and the objective. So let's start with those. Let's do units produced first. Okay, so you can select A16 to D16. Remember this, formulas tab, create from selection, left column. All right, so this range will be called units produced. Hit OK. Units used in production. You can select A18 to D18. And then formulas tab, create from selection, left column, OK. Hours used and hours available. So select B23 to B22 to B23. Formulas tab, create from selection, top row, OK. All right, for hours available, select D22 to D23. Formulas, create from selection, top row, OK. And then we need the objective, which is revenue from sales. So select A25 to B25, formulas tab, create from selection, left column, OK. Let me click on under formulas tab, name manager. So we got hours available, we got hours used, we got revenue from sales. We got units produced. We got units used. We need one more. So we need units sold. Where's that? Okay, so this, we should have done that the same way. So units sold is right here. There's nothing in there yet, but we need a range name for units sold. So if you want to select A19 to D19 right here, and then formulas tab, create from selection, left column, okay. And then under formulas tab, if I click the name manager, we got hours available, hours used, revenue from sales, units produced, units sold, and units used in production. So those are the six range names we set up. Yeah? So we got those. All right, so step 3 is easy. We just need to put any trial values for the number of units produced in the units produced range, which is the decision variable range. So let's put some numbers in there for now, just in units produced. All right, I'm just going to put ones in for now, and then solver's going to figure out the solution later. So in this range, in the light red cells, you can just put ones in there. Okay, and we'll figure those out later. All right, step 4. Let's calculate the units used to make other drugs. So in G16, let's put in this formula. All right, G16 is over here, over in the little chart on the side. All right, so the formula is equals B7. B7 times B $16. Okay, and so what this does is it's telling us how much of of the drug we need from the other drugs to make this drug. And so drug A is only made of drug A. So it's only going to be from drug A. But you see that this is how many of the previous drug we need to make this drug. And we don't need anything. We just need to make drug A. So for drug A, it's just going to be nothing. Okay. But then we can drag that across from G16 to I18 to tell us how many drugs we need to make the other drugs if we need them. Okay, so this is the formula equals B7 times B $16 in B16. Now you can apply that to the rest of this chart. Okay, so grab the bottom right corner and drag it across like that to I16. And then if you have these three selected, or select G16 to I16, you can grab the bottom right corner of that and drag it down to get drugs to get these rows like this. Okay, so this should sync up with the chart. We don't need any drug A's, B's, or C's to make drug A. We just need to make drug A. We need two drug B's to make drug. We need two drug A's to make drug B, and we need one drug B to make drug C. So see how it's just it's copying the logic here, but it's going to help us calculate the model. So you should have zeros here, a 2 there, and a 1 there. Yeah. Okay. And then we need to get the total used of each drug in the J column. So in J16 equals sum. Equals sum of G16 to I16. So the sum of this row, and then enter. Okay, and then you can apply that sum function down. So just click on J16, double click or grab the bottom right corner and drag it down 2 cells. All right, so that's the sum of that row, which is 2. That's the sum of that row, which is 1. And that's the sum of that row, which is 0. All right. Now we need to do next in step 4 still is we're going to use a transpose function. Okay, we're going to do this step. And we're going to select more than one cell and just type in the transpose function. And when we enter it, you don't just hit enter because you're doing multiple cells at once. And so I'll show you, but you have to hit Control Shift Enter at the same time. So the transpose function, the transpose will copy a column to a row or a row to a column. So like we're going to copy this range to this range. Okay? Or you could also copy a row to a column. It has to be the same number of cells total. Okay, but that's what it's a pretty useful function, the transpose function. So if you want to copy and paste a formula or a row or a column to a row, you can do that, or you can copy and paste a column, or I mean a row to a column, either way. So in this case, we're going to copy and paste these 3 cells in the column to these 3 cells in the row. So this, and this is going to go right here, here, and here. And then whatever happens here gets automatically put here. Okay, so the step is first select B18 to D18. Okay, so select these 3 cells, all of them, and leave them selected. And then while they're selected, just on your keyboard, type in equals transpose, and then in the transpose parenthesis, J16 to J18. Okay, so equals transpose, and in parentheses J16 colon J18, see how it's selecting that. All right, and don't hit enter, hit shift control enter. So hold down the shift button, like it says on the steps, hold down the shift button, then hold down the control button, then hold down the shift button, and then hit enter. All right, and so that hopefully works. And see how it's got the transpose thing up there? So when you type in the formula, you got to hit shift control enter at the same time. And see how it says equals transpose, equals transpose, equals transpose? Okay, did that work?
It didn't work for me.
No, it didn't work? Okay, let's try it. So, you have shift, if you're using a Mac, you have shift control enter, right? You have all those options?
Yeah.
Okay, so let's try it again. So you got to delete this. Okay, so you got this over here. This one is equals some of that, and some of that. So we're trying to transpose that formula over here. And to do that, so first select B18 to D18, right? And then with those three cells selected, just type in on your keyboard equals. Transpose J16. All right, so equals transpose J16 to J18, so we got that. Yeah, and then here, you don't want to hit enter, you want to put your finger on the shift button, then put your other finger on the control button, and then hit enter with your other hand. All right, so you're holding down shift, you're holding down control, then hit enter.
Okay, it worked now. Thank you.
Okay. So you gotta do everything at once. So okay, so that everyone got that? That worked? And if it did, you should see here it says equals transpose J18 to J18 equals transpose. Yeah, so it's like it's set up the formula. So whatever goes over here, here and here is going to go here, here, and here. All right. Okay, so we got that. Okay, so we did step 4. Step 5 is to calculate the units sold. Okay, so let's put this formula in B19. B19 is right there. The formula is equals. Okay, equals B16 minus B18. All right, and that's just, we use this many in production, and we produce this many, and we use this many in production, so the remainder, or the leftover, is what we sell. Okay, so we can either use it in production, or we can just sell it. All right, so that minus that is how many we're selling for each type. So in this case, it's going to be 1. Or in this case, it's going to be negative -1. All right, and then if you got that, in B19, you can grab the bottom right corner and drag it across like that. Okay, so we got equals C16 minus C18 here. And we got equals D16 minus D18 here. So when this model is solved, we can't produce more than we use in production for each type. And then this column will tell us how many of each drug we sold. Yeah. All right, so let's calculate the labor hours used in B23 with this sum product function in step 6. Okay, so in B23 equals Okay, equals sum product, in parentheses B5 to D5, comma, units produced. Okay, so this just calculates the total hours used based on how many drugs. So each drug A we produce requires 1 hour. Each drug B we produce requires 2 hours, and then each drug C we produce requires 3 hours. So the total number of these we produce at these hours is the total. So this times this, plus this times this, plus this times this is the total hours used. Yeah. Okay. So we should get 6 for now, but we have up to 4,000 to use to do this. All right, so step 7, total revenue of the objective. So let's put this sum product function in B25. All right, so in B25 equals, okay, equals sum product in parentheses B12 to D12, comma, units sold. Okay, so what this does is it calculates our total revenue from each of the types. All right, so if we sell this many drug A's, we get this much per drug A. We sell this many drug B's, we get this much per drug B, and we sell this many drug C's, we get this much per drug C. So that times that, plus that times that, plus that times that is the total revenue we get from selling all the drugs based on how many we sell and what the selling price is in the market. All right, so right now we get 92. All right, so the next step we've set up the model is going to be to use solver to maximize revenue. Everyone good so far with all these steps before we use the solver? Okay, so the next step is going to be to use solver to maximize revenue with this project. So step 7 is let's use solver to maximize revenue from sales. That's our objective by choosing the units produced range. We have two constraints. All right, so let's do that. All right, so we're going to use solver. So data tab, and then click on solver. You should have solver now. Click on solver to solve. Okay, and let's specify what we're doing. The objective, hit that button, is B25. Choose that. We're going to maximize that, so you can leave that there. By changing variable cells, you can hit this button and choose just the red cells, the units produced range, B16 to D16, and hit the button to choose that.
Hey,
All right.
Professor.
Yeah.
What tab is solver under again?
Oh, so just hit the data tab, and you should see solver over there on the top right. Under data tab, yeah.
My solver's not here anymore.
Okay, so you might just need to recheck it. Let me. So
Yep.
when you hit the data tab,
I just have to recheck it. I got it.
yeah. Okay, you know how to do that.
Yep. Thank you.
All right. So when you get solver again. Okay, so we chose the objective, which is B25, and we're going to maximize that. And our by changing variable cells is B16 to D16. Okay, so that's the units produced range, and we have two constraints. Hit the add button for the first one. Okay, so the first one, let's specify the production constraint, which says that units produced has to be greater than or equal to units used in production. So cell reference, hit that, is B16 to D16. Choose that, that's greater than, so flip the sign around there to greater than. The constraint is units sold, which is B19 to D19. Okay, so this constraint, cell reference B16 to D16 is greater than or equal to B19 to D19. Hit OK. Okay, so we have one more constraint, which is the labor constraint. So hit the add button, and let's specify that hours used have to be less than or equal to hours available. So cell reference is B23. Choose that. Less than or equal to constraint is D23. Choose that. Okay, so cell reference B23 is less than or equal to constraint D23. Okay? Okay. All right, then we make sure this box is checked, make unconstrained variables non-negative, and make sure the solving method should be simplex LP. So look at your parameters. It should say objective is revenue from sales, maximize by changing variable sales units produced, and we have constraints hours used less than or equal to hours available. Units produced is greater than or equal to units sold. This is checked, and this is simplex LP.
Does your top box say revenue from sales?
Yes, it does. Yeah. So revenue from sales is the objective, the highlight yellow cell.
Mm-hmm. Okay, gotcha. For sure.
B25, right?
Yep.
Okay, I'll leave it. Are you still putting in the parameters, Tyler?
No, I got it. My bad. Okay.
All right, so let's hit solve. And hopefully we get a solution. Hit OK. That doesn't look right. We shouldn't. Yeah, I believe we should have got 70,000. Let me. Um, all right, something went wrong. Did everyone else get 108,000? Because we can't sell negative 4,000 of something.
Yeah, I got the same issue.
Yeah, I got the same thing.
Okay, so at least we followed along, but this is not what I normally get here. So what do I do differently? All right, let me pull up the finished one and see what we did wrong. Huh, I don't know what's going on here. All right, so the solver's right. I don't see how we're getting. All right, well let's go on to the next step and see what happens. Okay, so let's run solver again and see if we get a sensitivity report. All right, so let's just run the solver again. All right, so data solver. All right, and hit solve. Okay, and then when you get here, see where it says reports. Click on sensitivity and hit OK. And it should give you this report here. All right, and so what this tells us is the shadow price for the labor constraint, even though this model is not working out right, but I don't know, this is, all right, so this would tell us that getting one more labor hour would give us another $27, but it doesn't make any sense because we have negative. I don't understand how we could have negative 4,000 sold for drug A. So that does. Okay, so the solver table isn't. None of this is going to work if it doesn't solve right. So it don't. All right, let me check this one more time, and then I'll see if I can figure it out. Oh, wait a minute. Okay, I think I've figured it out. So this should say on the solver we should have hours used less than or equal to hours available, and units produced greater than or equal to units used in production. Oh, okay, that's what I meant. All right, all right. So I'm glad I figured this out, but sorry about that. All right, so this should work. Okay, so click on data, and then click on solver again. All right, and then when everything is correct except for one of the constraints, so click on this one, the units produced, and just delete that. So just click on it and hit delete. All right, so we got everything else in the hours used constraint. Okay, and then let's add the right constraint. So click on add. Cell reference, hit that button, is units produced, B16 to D16. Okay, and so that's greater than or equal to. The constraint is units used in production, B18 to D18. All right, so the correct constraint, I think, is B16 to D16 is greater than or equal to B18 to D18 and hit OK. And so it should instead now say units produced greater than or equal to units used in production. All right, and then everything else should be the same. And so if you got that and hit solve, and OK, yeah, all right, that's it. Okay, so I somehow said this was the constraint instead of that. Okay, so did that work? Do we hit 70,000 now?
Yeah, it worked.
All right, great. Sorry about that. I was driving me crazy. Okay, so now I can tell you what the solution means. So what happened here is we produced 2,000 A's, 1,000 B's, and no C's. Okay, and then look at what we sold. We didn't sell any A, we didn't sell any B, but we sold 1,000 B's. So we didn't sell any A's, we didn't sell any C's, we sold 1,000 B's. Okay, and we used all the hours that we had, the 4,000. And by doing that, we get a revenue of 70,000. Okay, and you'll see, I'm going to show you doing the sensitivity report and the tables that the solver is going to find the drug that's most profitable in terms of the revenue that's produced from the hours that go into labor. And it turns out that in this case, drug B is always the best option to sell because it takes the least amount of labor to get the most amount of revenue. All right, so I guess revenue per labor hour is the term. All right, so let's delete this one. Okay, the old sensitivity report, just right click it and delete it. And let's do that again. So data, and then solver, and then solve it again. When you get here to the solver results, under reports, click on sensitivity and hit OK. All right, so what this tells us for the labor is more accurately interpretable than last time, which didn't make any sense, is we used all 4,000. Right, we had 4,000 labor hours, we used all 4,000, and the shadow price for another labor hour is $17.50. Okay, so if you go back to the model, the reason why it's $17.50 is because it takes 4 hours, takes 4 total hours to make a drug B, and that selling price is 70. That's the one we're selling. So we're selling 1,000 of these at $70. So that means 1 hour is a fourth of this production. So 17.5 times 4 should give us 70, right? So okay, so that means that if this takes 4 hours to make $70 on the market, then each of those hours is worth $17.50. So we'd actually need 4 more hours, but you can see the value of essentially if you get 1 more hour, you get a fourth of the new drug. If we were given 4 new hours, we'd be able to sell 1 more drug B, and we'd make another $70. Okay, that's what that means. So let me just show you what would happen. Okay, so don't do this, but if you gave yourself 4 more hours, and I rerun the solver, that's going to give us 1 more drug B to sell at $70. So the shadow price is 4 hours times 17.5, so we'll make another $70. So if I run the solver, we should get a new revenue of 70,070. Yeah, see that? So we got 4 more hours. That gave us enough to make 1 more drug B, and that's exactly why the shadow price is 1750, because that's a fourth of drug B. All right.
Wait, what did we change in our solver the second time?
Oh, so solver, you changed this constraint here. So before I incorrectly put it as units produced is greater than or equal to units sold. Instead, it should be units produced is greater than or equal to units used in production. So the range of that is, or when you select the new constraint, it's B16 to D16 is greater than or equal to B18 to D18. And if you put in the range names, it should give you this.
Okay, thank you.
Okay, so drug B is sold. All right, so I'm gonna do a couple solver tables. And again, the solver tables are not required for credit for the exercise. So if you can do the solver tables in step 9 and 10, great. If you can't, don't worry about it. So for full credit for this assignment, steps 1 through 8 are all you need up to this point. Solver tables are optional, but let me show you a couple of solver tables. Okay, so let's create a one-way solver table where the drug A selling price is along the side and how that affects units sold and revenue from sales. So the point is, for these solver tables, is right now, we're only selling drug B, which means that drug A and drug C are not worth it in terms of the labor that it takes to make them and the revenue you get. So there must be some higher market price if drug A rose to that would give us the same amount of revenue or more compared to drug B, and that's the point of the solver table. So if you can do solver table, where's my solver table? All right, solver table. If you're doing it, again, this is not required. Run solver table. Yes. One way. Okay. Okay, so the input cell is the drug A selling price, which is B12. Okay, and we're going to change that to something above 8 because 8 wasn't worth it. So let's make it go up to maybe 20. Okay, so 8 to 20 in increments of 2. And let's see how that affects the units sold and the objective. So output cell is B19 to D19, comma, hold down control and choose B25. Okay, so we're trying to see how the drug A selling price, if that goes up, how that affects the units we sell, and then also the revenue. So hit OK. All right, so even if you can't get the solver table, you can see exactly what's going on here. This is how much we sell of A, B, and C, and this is our revenue. So see what happens? If drug A is $8, $10, if it goes up to 18, then we start selling drug A. So see what happens if we go from 16 to 18, if the demand goes up for drug A and the market price goes up to $18, that becomes more profitable than the other two types, and we only sell that type. See how it flips from we're selling only drug B, drug B, drug B, then all of a sudden, all right, drug A is the best one now. Okay? So the drug A selling price would have to increase to at least $18 for only drug A to be sold. Okay, so let's do one more little solver table for drug C, and then we'll do a practice problem. Okay, so let's do this one for drug C. Let's see how, if drug C price goes up, what happens there. Okay, so if you're doing the solver table, click on the model tab again, and then solver table, run solver table, yes, one way, okay. Okay, the new input cell is for the drug C price, so hit this and instead choose D12. That's the drug C selling price. And so drug C is currently being sold at 100. That's not worth it in terms of the labor hours that go into it. So let's increase that from 100 to maybe 150 in increments of 5. All right, and this bar is the same. So here we're trying to see how D12, which is the drug C selling price, if that goes up to what makes that worth it? And these down here are the same units produced and revenue from sales. So let's hit OK. All right, so see what's going on. This is for drug C. That's how much we sell of C, of A, B, and C. Currently, we're selling B only. But if the drug C price goes up to 125, okay, well, then we start selling that. So see how 120 not worth it. 125, all of a sudden, drug C is the best one to sell in terms of the bang for the buck for labor, and we start selling that. So if drug C goes up to 125, that becomes the one that we sell. Okay, let me just prove to you that this makes sense. Don't do this, but if I change this one to at least 125, okay, we're gonna sell only that, right? And our revenue is gonna go up a little bit. So let me change this to 125. Okay, rerun the solver. All right, see what happened? What did the chart told us that we'll start selling 571 drug Cs if the price goes up to 125. And what happened? That's exactly what we did. And we got a little more revenue, right? Because this one became a little more profitable. Okay, so it all depends on the revenue you get for the hours that go into production because there's only one input here, which is labor. All right, so let's do a practice problem real quick, but we're done with this one. So you don't, if you have the solver tables, that's great. If you don't worry about it. All you need for this one is the model solved to get the 70,000, and then also the sensitivity report showing that one labor hour is worth, one more labor hour is worth $17.50. So this is the completed model for full credit. That goes here. Someone's already turned it in. Yeah, Tyler's already done with it. So, okay. So when you finish that one, the drug production, just post that in Example45. Okay. And let's do one more, or let's do one practice problem, and then we'll be done with this. All right, if you click on Example45 practice question solved. Okay, so we'll do a practice question here, and then I have some, the exercise we're going to do after the spring break is based on this. So make sure you understand this concept where we got, here's the labor hours for the drugs, and then here's the drugs that go into each type. Now, sometimes I change these two things and also the selling prices, but the analysis is the same. Say part A. Okay, for this one, assuming no changes, what drug is sold exclusively and what explains these results? Okay, for this one, oops, just look at the screen cap and see units sold, and only one of the drugs is going to be sold initially. So units sold, drug A 0, drug B 0, drug C 5,000. 500. So drug C is sold exclusively, and the term here is revenue per labor hour is what explains these results. So what is the revenue per labor hour for drug C? So revenue per labor hour is just the unit selling price divided by the labor hours that goes into that drug. Okay, so that's the general formula. Always use that to compare these. And let's calculate the revenue per labor hour for drug C. So the unit selling price is 800. Okay, that's given right there. But you have to know how to figure out how many hours it takes to make each drug. So it takes 8 hours, and let me show you why. Okay, so it takes 1 hour to make a drug A. Okay, it takes 2 drug A's and 2 hours to make drug B. So that's 1 hour for that one drug A, 1 hour for the other, and then 2 more hours to make it drug B. So it takes 4 hours total to make a drug B. And then you need 1 drug B to make a drug C, and then 4 more hours. So it took 4 hours to make this drug B, and then 4 more hours to make it drug C. So 4 plus 4 is how we get the 8 hours to make drug C. Okay, so let me see if I can. All right, so the hours to make drug C are a component of the hours from drug A, the hours from drug B, and the hours to make it drug C. So if you do that, okay, so each drug A, so, well, maybe this is not the best way to use. So let me see. Okay, oh, yeah, so you only need a drug B, right? So there's no drug A's here, all right? So that's 0. Okay, for drug B, you need 1 of them. So 1 drug B. And then how many hours did it take to make a drug B? Okay, remember it was 2 plus 2, which is 4. Okay, so 1 drug B at 4 hours, and then you need 4, and then the hours to make it drug C are right there, so it's 4 hours there. Okay, so you don't need any drug A's. You need 1 drug B, which is 4 hours to make it, and then 4 more hours to make it a drug C, which is a total of 8. Okay, yeah, you see that? And then that's what explains this. So it sells at $800. It takes 8 hours to make it, and then the revenue per labor hour, which is the revenue per hour of labor, is 800 divided by 8, which is essentially $100 per hour. So each drug C is giving us $100 per labor hour. All right. So then part B, we're essentially doing the solver table manually to see what the other drugs would have to rise to be profitable. So A's price needs to be greater than or equal to what for only A to be sold. All right. So currently, the revenue per labor hour for drug A is A's price, and it takes 1 hour to make drug A. So right, just 1 hour to make drug A. Okay, so what price would A have to rise to for A's price divided by 1 to give us $100 per hour? Okay, to be comparable with drug C. So that would have to be 100. So 100 divided by 1 for drug A gives us $100 per hour revenue per labor hour for drug A. And if A's price went up to at least 100, currently it's 90, if it went up to 100 or more, then we'd start selling. If it was 100, it would be exactly comparable to drug B. If it went above that, we only sell drug A, right? So what I'm saying is if drug C is $800, it takes 8 hours to make it. That gives us $100 per labor hour. If drug A's price went up to 100, it takes $100 1 hour to make it. That would also give us $100 per labor hour. So if this was 800 C, and this was 100 drug A, they'd both be giving us exactly the same amount of $100 per labor hour. Okay, then part C is B's price needs to be greater than or equal to what for only B to be sold. All right, so let's do the same thing for B. So the revenue per labor hour for drug B, so how many hours does it take to make a drug B? Okay, so see, you gotta go backwards, and it takes 2 drug A's. Each of those takes 2 hours, and then 2 more hours to make it drug B. So it's 2 plus 2, giving us a total of 4. Okay, so 1 hour for one of these, another hour for the other one, and then 2 more additional hours to make it drug B. So 2 plus 2 is 4. All right, so what price for B, given that it takes 4 hours to make it, gives us exactly $100 per hour return? All right, well, obviously that would be 400. So 400 divided by 4 hours also gives us $100 per labor hour. So if drug B's price went, now it's 350. If it went up to 400, then it's comparable with this. If it went above that, then it's the most profitable one. So we're trying to find the break-even point for all the drugs in which they're all equal to the same revenue per labor hour. In this case, the benchmark is 100. So if B's price is greater than or equal to a 400 for only B to be sold. So what we've learned is that given the labor hours that go into it, because that's the only input, revenue per labor hour would be $100 per hour for all if drug C was 800, drug A was 100, or drug B was 400. All right, those make them exactly comparable. And if any of those prices go above that benchmark, then we start selling that. And that's why we're selling this one now, because these currently, A and B, are giving us a return of less than $100 per hour. So like 90 divided by 1 is 90. That's less than 100. And 350 divided by 4 is something less than 100. Okay, so the idea here is there's only one input to the production process, which is labor, nothing else. And so therefore, whichever drug is the most profitable in terms of revenue per labor hour will be sold exclusively. So for this type of problem, look for the only drug that is being sold initially, A, B, or C, calculate the revenue per labor hour for that drug, then determine what the selling price for the other drugs would have to rise to give that drug, to give the drug company the same return in revenue per labor hour. Okay, so we'll do some more practice with these, but it's a little tricky, but it's kind of fun because it helps you understand, you know, if you only have if you have one input in the production process, then uh, your your choice of selling only depends on kind of the bang for the buck for the labor that goes into it. Okay. All right, great. Questions on this problem here? Okay, so that's the practice problem. We'll do some more of those. Okay, so after the spring break, we're going to do this drug production assignment, and so it's basically a bunch of examples like that. All right, so we'll do some more practice with that one. But for turning in wise, all right, so your grades should be updated for all these assignments and these assignments, yeah? And then this one that we did Monday and this one that we did today are due Monday, March 22nd after the spring break. So you can post those whenever you're done to Blackboard. And then I'll get your grades updated for the midterm one probably sometime this weekend. I'll send an email saying that. But other than that, we're almost done. And remember, no class next week. Spring break for Laverne. So we'll resume if everyone comes back, hopefully in week 8 on Monday, March 22nd. So it seems like a ways away, but we're still only like a little more than a third of the way done. So okay, so I think that's it for this and for this week. So make sure you get your assignments in, and everyone have a safe spring break and enjoy your time off. And I'll see you everyone in 2 weeks, or I guess a little bit less, but Monday, March 22nd. All right, so that's it. Stay safe, and thanks for joining.
Yeah.
Thank you.
Thank you, sir.